Today we can discuss the third chapter, classification and periodic properties. Classification of elements and periodicity in properties. That is the third chapter. Now there are 118 elements. What is the need to classify these elements? That is the first question that we have to face in this chapter. Why do we need to classify elements? The number of elements, large number of elements, 118, that is a large number. Each element has its own properties, chemical, physical properties. So it is very difficult to study individually the chemistry of all these elements and their innumerable compounds individually. To overcome this problem, a systematic classification of elements required. So classification of elements, that is needed. Then only we can study the properties of all these elements and its compounds. The first effort was by Doberino. In 1829, he classified some elements into groups of 3, which he called triads. Triads, a group of 3. The elements in a triad had similar chemical properties and similar physical properties. And here you can see examples: chlorine, bromine, iodine, calcium, strontium, barium, lithium, sodium, potassium. He classified these elements on the basis of a law known as law of triads. That is explained in the example: lithium, sodium, potassium. What is the atomic mass of lithium? 7. Sodium 23 and potassium 39. Here the atomic mass of sodium 23. It is given as 26. It is 23. 23 is the average of atomic mass of lithium and potassium. 7 plus 39, 46 divided by 2. That is equal to 23. Okay, here it is law of triads. In law of triads, that is a group of 3, and here the atomic mass of middle element is the average of first and last element, atomic mass of first and last element. That is law of triad. So atomic mass of potassium 23, average of lithium and potassium 7 plus 39, 46 by 2 is equal to 23. But law of triads works only for a few elements, so it was dismissed. Cannot be applied to the complete elements. And now the second important effort was by Newland's octaves. He observed when the elements are arranged in the increasing order of their atomic masses, the 8th element has similar properties as the first one. For example, here you see from lithium, 1, 2, 3, 4, 5, 6, 7. Now sodium is the 8th element. Its properties are similar to that of lithium. We know sodium and lithium belong to the same group, that is alkali metals, first group. They have similar properties. So that is law of octave. The property of 8th element is same as that of the first element. But he arranged about 20 elements in this way. After that, he failed. And another important effort from the part of Lothar Meyer. Lothar Meyer studied the physical properties and plotted these physical properties. Ionization energy. Now we will call it as ionization enthalpy against atomic number. And then he got a graph in which the elements in the same position of the graph. For example, in the peak, you see helium, neon, argon, krypton, xenon, radon. All these are noble gases. They have same properties, so he can classify it into groups. Lithium, sodium, potassium, rubidium, cesium. If you select this part of the graph, that is, all these elements belongs to the same group, that is first group, alkali metals. It was done by Lothar Meyer and effective classification, but he failed to complete it. Then we can say a successful classification by Mendeleev. So he was able to classify all the non-elements into groups and periods, and based on this he prepared a periodic table, that is Mendeleev's periodic table. In 1869, a Russian chemist Dmitry Mendeleev classified the various elements on the basis of a law called Mendeleev's periodic law, which states that the physical and chemical properties are the periodic functions of their atomic masses. The law is important because it was the first successful systematic classification of all the non-elements. You have to state the law as it is given here. The physical and chemical properties are the periodic functions of their atomic masses. Physical and chemical properties are the periodic functions of the atomic masses. Mendeleev arranged elements in horizontal rows and vertical columns of a table in order of their increasing atomic weights in such a way that the elements with the similar properties occupied the same vertical column or group. So if we take a group, all the elements in that group have similar properties. But when he arranged it in the order of atomic masses, some errors had happened. Now we can see what are the features of this Mendeleev's periodic table. Here you can see these vertical columns are named as groups. How many groups? 8 groups. And horizontal rows are named as periods. How many periods? 1, 2, 3, 4, 5, 6. Here you can see only 6 periods, but there are 7 periods. Here, lithium, sodium, potassium, rubidium, you see all of them have similar properties. But there are some variations in certain parts. For example, along with the fluorine and chlorine, you can see manganese. Fluorine and chlorine gases highly electronegative, but manganese is a metal with electropositivity. Such a variations we can observe because it is arranged according to atomic masses. As the main features, it is listed here. The horizontal rows in the periodic table are called periods. There are 7 periods. These are numbered from 1 to 7. Properties of elements in particular, period shows regular gradation from left to right. That may increase or decrease. There is a regular gradation. Vertical columns in the periodic table are called groups. There are 8 groups numbered from 1 to 8. Group 1 to 8 are further divided into A and B subgroups. Some cases you can see it. Now, what are the merits of Mendeleev's periodic table? The first important merit, it was the first successful systematic classification of all the known elements. First successful systematic classification of all known elements. The second one, Mendeleev kept some blank spaces in his periodic table. These vacant spaces were 4 elements that were yet to be discovered. He left places for the elements to be discovered. That is an important merit. Another one, he also predicted the properties of that elements even before they were discovered. He was able to predict the properties without knowing the elements. Later, they were found to be correct. He predicted the properties of scandium. At that time, it was not discovered, therefore, he named it as Eka boron. Similarly, predicted the properties of gallium. He described it as Eka aluminium. Predicted the properties of germanium, and he described it as Eka silicon. After silicon, that is the meaning. Now the fifth one, when noble gases were discovered later, they were placed in Mendeleev's periodic table without disturbing the positions of other elements. There were enough space to accommodate these noble gases. And the fifth one, corrected atomic masses of certain elements. For example, beryllium, gold, platinum. By the experiment, they calculated a different value, but using this periodic table, Mendeleev corrected the atomic masses. Great achievement. But it has some failures also. We can see what are the failures of Mendeleev's periodic table or defects of Mendeleev's periodic table. Here, only 3 of them are given. Position of hydrogen in the period. There is no correct position for hydrogen in the periodic table of Mendeleev. You can observe anomalous pairs in the periodic table. For example, argon and potassium. Argon is a noble gas, potassium highly reactive alkali metal. They are given as a pair, anomalous pairs. It is not possible to consider them as pairs. Then it is based on the atomic masses. If it is based on atomic masses, there should be enough space to accommodate isotopes. For example, hydrogen has 3 isotopes. 1H1, 1H2, 1H3, but there is no space to accommodate these isotopes of hydrogen. These are the failures. It is enough for today. You have to write down the notes.